Okay, Bismillahirrahmanirrahim. So starting from today, we are going to get to the roof of the building and talk about the application layer. Okay, so far we've been talking about an overview. We talked about many concepts and what protocol is, what service is, what client is, what server is, and so on. We talked about many terminology, many concepts, but now we have to put these concepts into perspective and highlight each layer and what are the specific protocols that we use in each layer, how they work, and how they interact together. So the first layer, of course, is the application, which is the interface between the user and the network. So that's the entity that creates the content so that we can transfer it over the internet. The messages, the data itself, it gets created in the applications. Okay, so therefore applications are the interface between the user and the network. Of course, not all applications have to connect to the network, although many of them nowadays do. But most of the applications they create some content to be delivered over the networks, and these are the applications that we focus on. So, of course, in terms of the reference model, we talked about OSI reference model and we talked about TCP/IP reference model. So in the OSI reference model, application layer is represented by layer 7. Okay, whereas for TCP/IP, as we will see in a second, it's represented by layer 4 or 5, depending on whether you consider network access layer as one layer or two layers. The application layer is used to facilitate the message or the data exchange between two end applications. In order for this end-to-end application to happen, those two applications must use the same protocol, as we have talked about before. Of course, each layer, as we said before, implements or uses many protocols hand in hand in order to facilitate the communication over the network. As we will see, here in the application layer only, we have tons of protocols. And each protocol has certain functionality. And by having all these protocols work hand in hand, we can create the content and then send it over the network. So this is the mapping. Thank you. So this is the mapping between the OSI model and the TCP/IP model. Okay. So some people, they use network access layer as two layers. In that case, we will have application layer as layer 5, but here it's layer 4, and the application layer actually maps to 3 layers in the OSI model, as we have talked about before. So the functionality of the TCP/IP application layer protocols fits roughly into the framework of the top 3 layers from the OSI model. Okay, and but as we said, the TCP/IP model is the most common. The protocols that we talk about, other than the application layer, these protocols, they implement very little functionality, and that's why sometimes, or actually more commonly in the TCP/IP model, they are actually represented implicitly inside the application layer, as we can see here for the case of TCP/IP model. Okay. Some of the protocols that we use on a daily basis in the application layer are so the domain name services protocol, which roughly is used to map the name of the server into an IP address. So this is nothing but a lookup table where your computer stores the name and the IP address that corresponds to it. So when we say google.com, of course, the server address is not google.com. The server address is numbers. So DNS is the entity or the service or the application layer protocol that actually maps this name into an IP address. The hypertext transfer protocol, or HTTP, is used to transfer files that make up the web pages. So this is the accurate representation of HTTP lies in the presentation layer of the OSI model. Okay, but using the TCP/IP model, it's an application layer protocol. So HTTP maintains the session between you and the server. So there is some kind of logical session that gets established between you and the web server to facilitate the transfer of information and request and the response. Simple mail transfer protocol is used for emails, obviously, and we'll talk about more details of that. Telnet is the terminal emulation. Emulation means that you connect on a server as if you are sitting in front of that server. So you create some kind of a connection to the server that allows you to run commands on the server exactly as if you are sitting on the server. We call it virtual terminal or terminal emulation. File transfer protocol is used to transfer files, obviously. So move files back and forth between you and the server. Okay. So the application layer uses protocols that are implemented within applications and services. What is the difference between an application and a service? Application usually has a user interface. This is the basic difference between the two. Service is what we can see when you go to Task Manager in Windows. You see a list of services. You see many names that you have not started. You have no idea about. These are software components that get triggered by the applications that you are running, or maybe get loaded automatically by the operating system to do certain service for you. It runs behind the scene to do certain functionality for you. Okay, so the application interacts with these services to do something, and what we focus on here is to interact with the network. So these services, they are used to send information back and forth to the network. Okay, and usually services is where you implement the actual protocols. So, for example, HTTP is a protocol that runs within a service, okay, that gets triggered by your web browser. Okay, so your web browser is an application because it has a user interface, right? So when you say google.com, you trigger HTTP, which goes to a specific service that runs behind the scene to know how to send this message over the internet through triggering the protocol which is called HTTP. Okay? So these protocols that get implemented within these services, they are then define the rules of communication, as we have mentioned before. They define the rules for communication, whether we have to start by saying something, we have to agree on a certain framework for conversation, and then we start sending the messages. The messages, what is the limit on this message? What is the header? What is the format of this message, and so on. These are defined in the protocol, and these protocols are implemented where? In the service, which gets triggered by the application. Okay. So the bottom line is that when we talk about Telnet, for example, okay, we can refer to a protocol because Telnet is a protocol. Okay, we can refer to a service because this protocol is implemented in a service that runs in the background of the operating system. Or we can refer to the application, because we have Telnet client that has a user interface. Okay, we have a Telnet client and Telnet server. So you can set up Telnet client and Telnet server on two machines. Nowadays, of course, we use SSH for security. SSH is secure Telnet. Okay, because security is a big issue nowadays. So SSH is nothing but Telnet, but in a secure way. Okay. So we can refer to the application because that Telnet application or SSS application has a user interface, or we can refer to the service, or we can refer to the protocol. The application layer protocol functions are encapsulated basically in this header here. Okay, so you take the content from the application, and then you have to add the header of the application layer protocol before you send it over the network. And you, of course, you use encapsulation to add or to append the application layer header to the data, and then you send it over the internet. So in order for you to send information over the internet, sometimes and in many cases, you need many other protocols to work with you, whether they are in the application level or in the transport layer header level or in the network level. So these are some of the protocols that get triggered once you start HTTP, for example. When you say HTTP google.com, you have to first get to DNS, because when you say google.com, this has to be mapped to an IP address. And to do that, you have to your browser creates a request, okay, which has a DNS header. And this is not the data. This is a request to the DNS server. And it will ask the DNS server, please give me the IP address for google.com. When it sends back the address, then and only then it creates HTTP header, and then it puts the data, and then it creates the CP header, and then in the IP header it puts the IP address of google.com and sends it. Okay. This is the ARP protocol, which is used to discover the IP address for specific physical addresses, and we'll talk about that in later chapters. But this is another application layer protocol that gets used. ICMPE is another protocol that gets used for error recovery in the network. And again, we'll talk about it when it comes in, I think, chapter 5 or something. But then HTTP uses the transport layer protocol like TCP or UDP, and it uses Ethernet or PPP, and it uses IP. So all these protocols, they get triggered by the application layer protocol in order to facilitate the full transmission of the information over the network. Sometimes, if these protocols they work in different layer, like transport layer, so you will find more and more of these headers concatenated together. If HTTP wants to trigger DNS, then from the application layer it triggers a request to get the information that it needs, and then once it's back, then the data gets processed, and then it creates these headers accordingly to send the message. So sometimes before you send a message, you need more pieces of information that are important to you. One of them is, or one example of this is the DNS. So you send a call to the DNS server, you get the response back, and then you send the message. Okay? And we'll talk about the DNS server and how you trigger it in details. So the application layer protocols work in two paradigms or two different types. Either client-server model or the peer-to-peer model. Okay? So the client-server model defines the concept of client and server and separates between the two. As we said before, the client is the entity that always initiates the communication. Okay? This is the application or the service that initiates the communication. It requests a particular service from the server. The server is the device or the application that then receives these requests and provide the service based on the request that it's coming. Okay, so the server itself is always running. It's supposed to be always running. Okay, that's why when you open a browser and say www.google.com, okay, Google will not start a new service for you in order to process it. It's always running. This is a web server that's always running. Okay. And because it does not know when the request is going to come. So the server is the entity that always runs, and it receives the requests from the client and processes it, and based on that it sends the response. So in addition to the actual data transfer, this exchange between the client and server may also require some user authentication, some identification, right? Because for example, if we access an FTP server, okay, and this FTP server hosts some confidential information or hosts some file content, which are very critical to the organization, so it's very key that we have to have some kind of authentication mechanism where the user has to log on, similar to MyQU here or something. So if you're not a student and you access MyQU, you may get to some confidential information that you're not supposed to get. So so you need some kind of authentication mechanism that allows the user to log in using user ID and password, so that we give the access only to people who are authorized to do that. So when you log in using your user ID and password, you have to identify yourself. You identify yourself so that the server knows exactly who you are. So when you get to see certain data, the server knows that it's giving you the access to this data because you are person X or person Y. So the identification is important here. So a server is usually a computer that contains information such as web server or email server or file. So in order for us to do our daily business, we on our machines we constantly have to use email, we have to use web, we have to use many services, and for all these services you have to have some servers, whether in the network here or in the internet, that provide you this service. Okay, so that's why if the email server is down, tough luck, you cannot see your email. Same like Gmail. If the server in the bank is down, tough luck, you cannot see you cannot see anything in your account. So all these servers, they have to be running in order for you to trigger these services. And of course, as we said, the authentication is important in that case. So, for example, if you request to upload data to the FTP server, this is actually a request that you want. It's not so to access an FTP server, it doesn't always work that you have to request a content from the server. Sometimes you need to upload something to the server, and that's also a service that you request. You are requesting to upload something. You have to always initiate. I want to upload something. Okay? It doesn't work the other way around, that the server will ask you, please give me the file. It doesn't work this way. You always, as a client, you are always the initiator of the request, whether it's upload or download. So you may have permission to write to your individual folder, but not to read other files on the site. And that's the importance of authentication. So for an FTP server, when you say upload, you upload to your individual folder. Okay? There is only one folder that you, or one or more folders that you can see, because you identify yourself and you authenticated yourself to the server. Okay? But that doesn't mean that you can see all the files on the server. Okay? So every individual has his or her own folder that he or she can upload files to without having to see others' files. Okay? So that's the important concept, which is the authentication. So starting from here, we'll go through the important protocols. And of course, we cannot cover all the protocols in the application layer or in any other layer. But we will go through some examples which we think they are important. And these examples are all of these. So we'll go through HTTP, of course, which is the predominant protocol over the internet. So FTP as well. We'll talk about the details of this. SMTP, Telnet, DHCP or dynamic IP addressing, and DNS, and SMP, which is it's kind of obsolete now. SMP. And P2P, which is also one of the very common protocols that are used nowadays. I think most of you, whether you use like eDonkey or BitTorrent or things like that, so all of these use the P2P file sharing or peer-to-peer file sharing. So this slide is very important because it tells us how the communication happens. So here we have HTTP. So this machine has an application which triggers HTTP service, and it communicates with the server. Okay? So this machine creates all the application layer header, transport layer header, IP data link, and so on. Okay? And then it sends this whole frame over the network. When it does that, through all the other devices, this part of the data is abstract, is just a unit of data that's sort of like an envelope closed. Okay? So the router here does not know anything about TCP or HTTP header. It's not supposed to read anything from these headers, right? And it goes all the way to the server. Okay? So there is an application-to-application communication. Okay? So this header here corresponds to this header here. And so when the server responds back, it has to send an HTTP header which can be processed and understood by this machine, and the other way around. Okay, so they exchange HTTP header to facilitate the bidirectional communication between the HTTP client on your browser and the HTTP server on the other side. In between is transparent. This information is transparent, is abstracted, and no one else is supposed to process this application layer header except the client and the server. So this facilitates the application-to-application communication. Okay? So the first protocol we talk about is the hypertext transfer protocol, and this protocol is used by the web servers, This protocol is summarized in two RFCs, requests for comments. Remember we talked about standards for IETF. So when you go to IETF, you can go to request for comments or RFC, and this is the number for HTTP. Of course, this is the HTTP version 1 and this HTTP version 2, or sometimes for the same protocol you update. You update the protocol to a later version by adding more functionality to it. When you add more functionality, you always keep the protocol backward compatible, which means that HTTP version 2 can work with HTTP version 1. Okay? But if you send HTTP 2 to a machine that understands only, if you send HTTP 2 header to a machine that does not have HTTP except version 1, then there is a problem. Okay? So if we talk the same language, then we can talk. Even if you know more information, more than myself, then this extra information I may not be able to understand it very well. So these RFCs sort of summarize and actually details all the functionality of HTTP protocol. HTTP protocol is implemented using the client and server model, which means that we always have a web browser talking to a web server. Okay, the web browser is the client. The current version is, of course, we have a later version more than that. And HTTP gets encapsulated into TCP. In fact, in some cases, it can be encapsulated in UDP as well. Okay, but as part of this course, we'll talk about encapsulation with TCP. But we'll talk about the difference between TCP and UDP in chapter 4. Okay. So this is the HTML file. So that's an HTML file. The HTML file contains some tags, as we can see here. So this HTML content looks like this if we display it in the browser. Okay, it's just my signature. Okay. So we want to get this content from the server. Okay. So this is the content of a web page, also called like HTML document. And web pages consist of objects, and these objects can be just simply HTML tags, like these ones, or they can refer to some other objects like an image or some applets and so on. Some applets will have some code that runs something and so on, or audio file or video file and so on and so forth. So all these, they get represented using HTML tags. Okay? So we need to, so this content here is hosted on a web server, and we want to send a HTTP request to get this content and get it displayed on our screen. Okay. So HTTP is the one that's responsible for this. What happens is that the browser is the user agent, which represents the client in that case, and it displays the requested web server, which happens to be my personal web page, and I'm just publicizing for my web page. So the browser and the client may be used interchangeably. So when we say browser, we mean the client. When we say client, we mean for HTTP, it's actually the browser. So HTTP has nothing to do with how a web page is interpreted. That's very important to understand. I don't care about the The HTML is the actual data. Okay? But HTTP, it actually processes the header itself. That's what it cares about, regardless of how the content looks like. The content for it is just text. And later on, over the network, is going to be just binary numbers. It doesn't care what's inside the data payload or the data part. It doesn't care whether there is an image, there is HTML tags, there are graphics, image, audio. It doesn't care. In addition to the data, the HTTP will append this text in the HTTP header. That's what we need to care about. This is what HTTP adds in terms of functionality. So the first thing is that the first thing that starts in the HTTP header is GET. So there are certain commands in HTTP. One is GET, one is PUT, and so on. So we talk about GET and PUT, and in 99.5 or 99% of the time, it's GET. We always want to get a content from the web server. The only exception, not the only, or one of the few exceptions, is when we fill some information and we want to, for example, buy something from Amazon. So you have to fill your information and you have to post your information to the server, and you only need some confirmation that tells you, okay, your payment is successful. So in that case, you want to upload your content, which is in that case your payment information and your billing information and so on. You need to upload certain content to the web server, okay? And the web server should process it and then gives you a response back whether it's successful or not. So in that case, we use POST command. But in most of the time, we use GET, which means that we need to send a request, okay? And we need to get some content. So, of course, the header has a lot more information than that. But this is just for summarization. So this is the command. This is they call it the URI, or the location, okay, on the web server from which you want to get the content. Okay? So you want to get some content in this directory on the web server. Okay? So sometimes you can get some content on this directory on a specific file. If you don't specify the name of the file here, this means that you use the default, which is index.html. So the default file name on this directory is called index.html. Okay? And you are using HTTP 1.1, and that's very important, as I said, because if you send this request to a server that only understands version 1.0, then the communication will not happen. Okay? Which means that if you as a client know HTTP version 2, for example, and you want to talk to a server and you know that the HTML version on that server is 1, then you have to send the request using 1.0. Otherwise, the communication will not happen. Because this version number has to match the protocol version on the server. Otherwise, the communication will not happen. Okay? And of course, you have to add more information. This is what we care about, really. So the rest of the information is just details. So this is the name of the web server. Okay? So in our very common example, we call it, like, for example, google.com or something. And this is just some metadata information which are important to be exchanged between the client and server. What we need to understand is really the get and the location where the file is and the version. And here is the connection which says keep alive. Keep alive here means that this request will be followed by other requests within that session. So keep this information. For example, when you want to purchase something on Amazon, okay, you have to establish some communication. You put some information in the cart, right? So when you go to confirm the purchase, you find all your items in the cart, right? So when you add items in the cart, you have to say keep alive, because that tells the server all the information that I'm giving you, you have to store it because you will need it later. Okay? If you don't say keep alive, this means that anything after that request, you can just destroy it. So if you don't send this keep alive in the requests, then everything that is stored on the server will get cleared out. So you will not be able to have any continuous communication with the server. Okay. So when we browse over the internet, in many cases we send requests continuously, and the information or the content for this request gets accumulated. So if we need that type of communication between us and the server, then we have to say keep alive. Otherwise, if it's just a simple request and then you get a content, but this content is not part of accumulated content, then you don't have to say keep alive. And this is an issue because if you say keep alive, the web server will keep storing the context, the context, and will keep storing more and more information on the server for you. So if you actually don't need it, you better actually not set this flag as keep alive, because otherwise the server will keep storing many information for you, which you don't need. Okay, so if it's like, for example, Google.com, if you say Google.com and that's it, and you have an HTML, halas, that's it. You don't have to say keep alive, right? But if you need to accumulate more and more information, then you have to set this. So, so there is the request line or the command line, which is this one. This is the most important one. And there is the header lines. And these header lines have more elaborate information about, the language that you're using, the encoding, whether you use like UB encoding UB8 or ASCII codes or which language you're using, some details. Okay. And of course the host number. And so the most important thing for us is the command, get or post. And we said that most of the time it's get, but in some few cases it's post. So this is the command line or the request line. So the get is the command that we send to the server. This CMPE is the browser is requesting the object in that directory, and the default is HTML, as we said. And this is the version, which is very important. Although HTTP is by default a client-server protocol, this is the exception here, is that HTTP is used in some P2P applications. In many of the BitTorrent and all these applications, they use also HTTP. So they have some workaround to have HTTP work even for the case of peer-to-peer. Okay, unlike the model which is client and server. Okay. So this is the HTTP response, and I think we can just talk about it next time because it has some details. So we'll stop here.